ahead lecture, and our topic for today is relation between the zeros and coefficient of a quadratic polynomial. In the previous class, what we have studied is value of a polynomial at a given point and zeros of a polynomial. So before moving toward this topic, I just want to introduce you one of the famous quadratic equation which is used so many times. I just want to introduce you and just want to give you some insight of this toward our previous lecture also. So let me introduce that quadratic equation. So the quadratic equation is x square plus 3x plus 2. Let us say it is equal to p of x. Okay. So I just want you to calculate the value of a polynomial at this point. So value of a polynomial p of x, that is this one, at these points. That is 1, 2, 0, minus 1 and minus 2. So these are my 4 points on which I need to find my value. So let us plot it like this. Let us say this is my x and this is my corresponding p of x, and this is my value at this particular value of x. So let us move sequentially. That is, let us move like this: 1, 2. Let us take. I have taken the value 2. So the value at 2, our equation is x square plus 3x plus 2. When we put 2 here, so it will become 4 plus 3 into 2 plus 2. So it is equal to 4 plus 6 is equal to 10 plus 2 equal to 12. So this value is 12. Likewise, if I take it as 1, then it will be 1 plus 3 into 1 plus 2. So it will be 3 plus 2, 5 plus 1 equal to 6. Value is 6. Then I take it as 0. So at 0, the value is 0 plus 0 plus 2. So it is equal to 2. Now if I take minus 1, so the value becomes minus 1 square plus 3 into minus 1 plus 2. That is equal to 1 plus minus 3 plus 2 equal to 3 minus 3 equal to 0. So the value is, here it is 0. Now take another value, that is minus 2. So minus 2 square plus 3 into minus of 2 plus 2. So what it's become like, minus 2 square is 4 plus 3 into minus 2 is minus 6 plus 2. That is 6 minus 6 equal to 0. So at these points, my polynomial is becoming 0. What are these points? These points are this: minus 1 and minus 2. These are my zeros of my polynomial equation p of x equal to x square plus 3 of x plus 2. So if I would plot on this on an scale, likewise, this is my y-axis, this is my x-axis. So if I take this is, so if I will plot this, so it will look something like this. and these are my, this is -1, this is -2. This is my polynomial equation p of x equal to x square plus p of x plus 2. Okay, so let me label this. This is x-axis, this is y-axis, this is 0. So these are my zeros. Okay, so now we will move to our topic, that is relation between the zeros and coefficient of quadratic polynomial. So quadratic polynomials mean it is of degree 2. Okay, so let me write down my expression that is of a quadratic polynomial. So the expression is, we have write the general expression. So general expression of degree 2, that is basically my quadratic polynomial, is p of x is equal to a of x square plus b of x plus c. Okay, so let us assume that alpha and beta are my zeros of this equation. That is p of x. Okay, so p of x can be written as k of x minus alpha and x minus beta. Now what is k here? K is some constant. Now what is constant? So constant is something which doesn't change its value. Okay, likewise 2, 3, 4 and so on, these are the number, these are constant because they doesn't change its value, because 2 is always 2 and 3 is always 3 and 4 is always 4, and many other number like 1.3, 1.2 and so on. So let us assume p of x is kx of minus alpha and x minus beta is equal to this equation, ax square plus bx plus c. Let me draw a line here so that we can separate it out. Now we need to compare this equation with this equation. Now let me break this equation. So this equation will break here like this, that is k here x square minus x minus of beta x, minus alpha into x is minus alpha x, minus alpha into minus beta is plus alpha beta. Okay, and our expression is this one, ax square plus bx plus c. So I differentiated with two color, that is black and red. So let me take x common here, so it will become alpha plus beta plus alpha beta. Okay, then opening this equation, it become like k of x square minus kx alpha plus alpha beta into k. Okay, now what we will do, we will compare the coefficient, of this equation and this equation. The coefficient here are a, b and c, and here the coefficient is k k and alpha plus beta plus this. These are my coefficients. So when we compare x square with x square, so it gives us a equal to k. Okay. Now compare this and this whole equation. This and this. So here is x. Coefficient of x here is b, and the coefficient of x here is k alpha plus beta. So k alpha plus beta equal to b. Okay. But here we can see there is a negative sign also. So I will add a negative here. Okay. And the c value is equal to alpha beta into k. Okay. Now moving toward this side, we will find that alpha plus beta equal to b upon minus k. Now what is k? K is equal to a. So it becomes minus b by a. So this is my first equation. Okay. And the second one is this equation. That is alpha into beta is equal to c by k or c by k. So in what we can write in this is that sum of zeros is minus b by a, and product of zeros is c by a. Now sum of 0, that is alpha plus beta. Product of 0 is alpha into beta. Now let me remind you one more time that this is for quadratic equation only. Okay, that is mean of degree 2. Not okay. So in the next class we will going to solve so many problems on the topic which we have studied. So, and I will also give you a link where you can find these notes also. So thanks for watching this lecture, and please subscribe to my channel. Thanks, Arthur.